بسم الله الرحمن الرحيم. We are still speaking about this topic, which is the gradient and direction derivative of scalar field. Last time we spoke about the directional derivative, and we said that the directional derivative is given by du f of x y, which is equal to the gradient of the scalar function f of x y, dot product with unit vector u. Today we are going to speak about the maximum and minimum value of the directional derivative. Make the maximum and minimum. When we say that the dot product of the two vector function gradient dot u, we have another form or formula for this one. This is equal to magnitude of multiplied by the magnitude of the unit vector multiplied by cosine theta. But we know that the magnitude of the unit vector is equal to 1. Equal to 1. So this is equal to cosine theta. So the directional derivative can be given the magnitude of the gradient multiplied by cosine theta between, or theta is the angle between the unit vector and the gradient. But we know that cosine theta is between 1 and minus 1. It means the gradient or the directional derivative d u will be between the gradient of the function f of x, y, minus the gradient. From this relation, we can say that the maximum value of the directional derivative is equal to magnitude of the gradient of the function. Of the directional is equal to magnitude of the gradient. This is one theta equal to 0. So when the unit vector is in the same direction of the gradient, then we have the maximum value when theta equal to 0, or when the unit vector is in the same direction of the gradient. And the minimum value of is minus the gradient, or the minus the negative of the gradient of the given function. And this is theta equal to 180, or cosine equal to minus 1. So the maximum value is when the unit vector in the same direction of the gradient, and the minimum when the unit vector is in the opposite direction of the gradient when theta equal to 180. And one more point from this one, we can say the gradient vector delta f point in the direction in which it increases most rapidly. Where minus the gradient of the function points in the direction of the most decreasing. Give me the direction of the most decreasing, and the positive will give me the most increasing direction. So examples for this concept or this idea. Find the maximum rate of x, y, z that's given by x squared plus 4xz plus 2yz squared. At the point 1, 2, minus 1. We need to find the maximum rate. Maximum rate. Rate means the derivative and of this one, and since we have a three-dimensional case, it is just the gradient of the function. So we need to find the gradient of the function. When you see this, find the maximum rate. So I need to find the magnitude of the gradient. So first of all, let's find the gradient of the function. That given by f sub x, f sub y, and f sub z. The partial derivative with respect to x, which is that will give me 2x plus 4z. Now partial derivative with respect to y is 2z squared. Now the partial derivative with respect to z will give me 4x plus 4yz. So we differentiate the function with respect to x, that will give me 2x plus 4z. Differentiate with respect to y, I will have 2z squared. Consider the other variables are constant. Now for the derivative with respect to z, I will consider x and y as constant, and then find the derivative that will give me 4x plus 4yz. Now at the given point, at 1 to minus 1, the gradient will be 1 to minus 1 is equal to, replace x by 1, y by 2, z by minus 1. So I will have 2 minus 4 and 2 multiplied by minus 1 square, and 4 multiplied by x is 4 plus 4 multiplied by y, which is 2 multiplied by minus 1. This is minus 2, 2, and I will have 4 minus 8 equal to minus 4. Now the maximum rate is equal to the magnitude of the gradient. That will be 4 plus 16, which is equal to square root of 24. So this is the maximum rate of the given function. If we need to find the minimum, just multiply by negative sign. It will be minus square root of 24. This is the maximum. If the question says find the minimum, equal to minus the gradient. This is minus square root of 24. This is not required in this question, but just in case, when it says that find the minimum, it will be this one. Let's take one application problem for maximum and minimum. Temperature at a point xy on a rectangular metal plate. Metal plate is given by T x y equal to 5 plus 2x squared plus y squared. We need to determine the direction an insect should take starting at equal to in order to call off. As possible. We have a rectangular metal, and there is a temperature function T of xy equal to 5 plus 5x squared plus y squared, and there is an insect. It's moving and should take some direction just to cool off the temperature. So we are looking for the direction in which the temperature will be decreased most rapidly. We are looking for the direction in which the temperature is cool off most rapidly. And to find that one, we have to find the gradient. We are looking for minus the gradient of T. We say that the positive gradient point in the direction of most increasing, and minus the gradient will point to the direction of the most decreasing. So we need to find minus the gradient of T. So minus the gradient of T equal to minus T sub x and T sub y. Partial derivative with respect to x and partial derivative with respect to y. That will give me minus. Differentiate with respect to x, I will have 10x. Differentiate with respect to y, it is 2y. Now at the given point for 2, I will have minus a gradient t at the point for 2 is equal to take the negative sign inside. Minus 10 multiplied by 4 is minus 40 or 40. 2y is equal to 2, I will have minus 4. So minus 40 minus 4. So this is the direction in which the insect should take to cool off as rapidly as possible. Just we need to find the negative gradient of the given function. If we are looking for the most increasing, we will take the positive. So this is the direction, minus 40 minus 4. If the question will say find the angle, we can find this also, an angle in which it is moving from the positive x-axis. But the angle for vector two-dimensional case is just in case the question is looking for the angle also. So this is the idea of the gradient, maximum, minimum, and most rapidly increasing and most rapidly decreasing for some values of some scalar function.